Okay, today we're going to talk about multiplying and dividing rational expressions. And before we start on that, I wanted you to think about just how fractions work in general. And I do have a lot more videos on fractions. If that's something you feel you want to brush up on, it could be very helpful in this unit. So I did post some links to some fraction videos as well. But let's think about, can you reduce the fraction 4/8? You can. A lot of you are saying yes. What does the 4/8 reduce down to? Okay, 2 over 4, good. 2 over 4 or 1 over 2. So a lot of you know that, but I don't know if you always know why that is. What you did mentally was you factored. You said 4 times 1 over 4 times 2. And then what does 4 over 4 equal to? 1. So we call this factored. Okay, or the factors. The factors of 4 are 4 and 1. The factors of 8 are 4 and 2. And then 4 over 4 is equal to 1 whole, which is the reason why if you multiply anything by 1, what we're getting here is the idea of equivalent fractions. 4 is the greatest common factor of 4 and 8. So that's why we're able to reduce it. Can you reduce 10 over 11? Okay, everybody, how many people are 100% confident you cannot reduce 10 over 11? I want you to be confident, okay? But I also want to show you something else. You cannot reduce it. Just hold on to that. You cannot reduce it, okay? Because 11 is prime. There's no number. There's no GCF other than 1 that will go into 10 and 11 evenly. But this is the same thing as 9 plus 1 over 9 plus 2, correct? That's not equal to 1/2. 10 elevenths is not equal to 1/2. You cannot cancel those 9s because of the whole idea of addition, right? You're not if I say 10 plus 1 over 10 plus 2, you're not able to cancel those 9s because it's not factored, right? So there's an implied parentheses here. And I don't want you to think that because I can write it like this, that's true, but it doesn't mean that it can be reduced down to 1/2. We know that 10 elevenths is not equal to 1/2, okay? So I just want to point that out because that's going to come up later, and that's going to become really important. So in this section, it will require that you really understand the concept of multiplying fractions. You want to be sure to reduce any numerator denominators, common factors before you multiply. And here are some examples. So if I multiply these two fractions, it's really nice. Multiplying fractions is so easy, right? We just multiply straight across. So if I go 2 times 5, that's 10. 3 times 7 is 21. Okay, this has no common factors. There's nothing that can cross cancel, so therefore 10 over 21 cannot reduce. Even though 10 over 21 is the same thing as 9 plus 1 over 9 plus what? 12? You see, that I just want to show you that it still can't reduce because it's all about the factors. There's a little bit of typo that's happening here. So this is supposed to be multiply. This one, I don't know what happened, but this is supposed to be divide. This is supposed to be divide, okay? So the idea of cross cancel is I could multiply across, but if I have to multiply 15 times 7 and 14 times 30, well, I don't know those off the top of my head. That's going to be a lot of work to multiply, and the idea is that I can cross cancel. Because 15 and 30, is there a common factor between 15 and 30? Yes, 15 goes in here once, 15 goes in here twice. What about 7 and 14? Once, twice, and this is, by the way, a negative. So we have 1 times 1, a negative, negative 1, over 2 times 2 is 4, okay? Now, so if I were to write that out as the factors, it's 15 times 7, and then 14 is 7 times 2. I can do that in any order. 30 is 15 times 2. So just so you see, that's the factored way of looking at it. And you're like, okay, well, here's 15 over 15. Here's 7 over 7. And so what's left is just the 2 times the 2 in the denominator, and then this is 1 because this is 1 and this is 1. So it's another way of looking at it, okay? When it comes to also having a negative with a fraction, by the way, just a little bit of a reminder, you could have, if you have a negative fraction, it means either the numerator was negative or the denominator was negative, but not both. Because what's a negative divided by a negative? Yeah. So you could put the negative either in the numerator or denominator, but you just can't put it both places, otherwise you're canceling it out. Okay? So here, if I'm going to divide fractions, who can remember what do I have to do to divide fractions? I get 5/7 times the reciprocal. You flip them. And so I don't say reciprocal, I usually say the refliprical, because it says flip. Anyway. Okay, so negative 21 over 20. Now, can I cross cancel anything here? 5 and 20, 5 becomes 1, 20 becomes 4, 7 goes into 21, how many times? And now we multiply across. 1 times negative 3 is negative 3. 1 times 4 is 4. That way, when you do multiply across, your answer, when you cross cancel, is going to be fully reduced. Okay? What about this one here? I'm going to start with 5/12, and I'm going to multiply by what? 6 over 25. Now I'm just going to switch colors so we can see about how we cross cancel. So 5 goes into 25 how many times? 5, so we cross cancel there. 6 goes into 12. And when we multiply across, we get 1/10. Good. Any questions about that? The other thing you're going to have to really know for this whole unit is factoring. So let's just review a tiny bit of factoring. So factoring a polynomial. Here we know these are all polynomials. They all have whole number exponents. Who can tell me how this one factors? You love that. And what do we call that one? Dots. Would x squared plus 25 factor? Would it factor the same way with the positive? Why not? Yeah, so this one we call prime, and you'll see this a lot, and you just saw it in your last bit of group work, and a lot of you were stumped on that. So you can always try to factor it, but then you might FOIL it to check and see that it's not going to work. Anytime you have a binomial with that addition and there's not a GCF, it's not going to be able to factor with the positive there. Okay, how would you factor this one here? Factor out a GCF. What's the GCF? And so you're left with, okay, that's another common one you'll see. And then what about this one? How would I factor here? Yeah, so this one was GCF was X. Here you could start with, well, you said AC method, which you could use, but anytime you have X squared in the beginning, you could really start with the X times X, right? What number is going to multiply to 16 and add to negative 8? 4. Okay, and what are the signs on the 4s? Both negative, right? Both negative. Another way of writing this is x minus 4 squared. And does anybody remember what we call this one? Yes, this is a PST, a perfect square trinomial. Difference of two squares, perfect square trinomial, two different ones. And that's why a lot of you, when you tried to factor this one as like x plus 5, if you FOILed it out, you get x plus 5. If you square that, it does not equal to that. You would get x squared plus 10x plus 25 if you FOIL. So you have to be careful about this one. Okay. Now, just a little bit of a reminder, and this is the reason why you might think, well, it's so weird that I would bring this up, right? About how you can't reduce the fraction, but I wrote it as an addition problem. Did anyone think that was a strange thing for me to do? Well, I'll show you why it is. What we're going to be getting into is simplifying rational expressions. So the really important thing here is that people will forget to factor. The number one rule of simplifying is going to be factoring. Okay, so you cannot cancel just the same way you couldn't cancel if we had 10 over 11 is 9 plus 1 over 9 plus 2. That's my favorite example to give because most students recognize right away 10 elevenths doesn't cancel, doesn't reduce, sorry. But yet, you'll see this happen a lot where people want to cancel the x's. The only way you can reduce a rational expression is when you factor. Only factors can be reduced. And that's the same way as when we saw 4 over 8 is equal to 4 times 1 over 4 times 2. We call that factored because it's all about breaking it into multiplication, right? So you will not want to cancel out over addition or subtraction. You can only reduce when you have common factors. Okay, and then once you reduce that common factor, you have to say, well, before I said x couldn't be 3 because that would give me a 0 in the denominator. Just because it canceled doesn't mean we're eliminating that possibility, right? What ends up happening actually is there's a microscopic hole in your equation x plus 3 at x equals 3. And we'll get into some more examples in just a minute.